Okay, so now I want to talk about some key concepts. I guess the big takeaways from STAT3101 that I haven't talked about yet, with an emphasis on topics that people have requested in the topic request thread. So first I'm going to talk about, I guess it's number 1, weak law of large numbers, right? So what the weak law of large numbers states that if we have x bar sub n, right, is the average of n samples from a distribution with mean equals to u, right? Then we have that x bar sub n, which again is equal to 1 over n sum of xi's, converges in probability to mu. Intuitively speaking, what this means is if we, for example, flip coins or some other random process with probability of heads of 0.5, right, and we're going to map it to heads equals 1, tails equals 0. Note that this means the expected value of x is equal to 0.5, right? Just mu. Then what converges in probability means. So what converges in probability means is that the probability that x bar sub n, right, or sample mean, being far away from 0.5 gets very, arbitrarily small. Right? Now, this is a very simple example or a very simple distribution to pull from, but any distribution with a finite mean is going to have that the sample average converges in probability to that mean. Now, to close this talk on the weak law of large numbers out, I want to just give you some numbers for this distribution to maybe help visualize that a little bit better. So what I'm going to do, I used R to calculate these numbers, but really there's plenty of tools online that could help you find the CDF of a binomial distribution. So I'm going to, for n equals 10, n equals 100, n equals 1,000, n equals 10,000, and n equals 100,000, right? And I'm going to do probability that 0.3 is less than or equal to x bar is less than or equal to 0.7. Probability 0.4 is less than or equal to x bar 0.6. And probability x bar is in between 0.49 and 0.51, right? Okay, so I calculated these numbers ahead of time. I'm not doing this as we talk, but starting with x bar being between 0.3 and 0.7. So we have about 77% for n equals 10, then for n equals 100, it shoots up to 0.9999447. Then for all of these, it's basically 1. Like, it's very incredibly close to 1 that R did not even show me anything besides 1. Right? So for that, the probability that we're going to be within 0.2 of our sample mean goes up to 1 very, very quickly. For this next one, we have... So initially, for n equals 10, the probability x bars between 0.4 and 0.6 is actually less than 50%. But don't worry. Well, large numbers wins. And it takes about the same amount of time, actually. But for this last one, that's a very tight range, right? Like, this is being within 1/100th of the sample mean, right? So to start out with, we actually only have a 24% chance, right? And then for n equals 100, we have 15% chance. So it's going down initially. And you may be worrying, does this mean the law of large numbers is wrong? But don't worry, it's not. And even for this very, very tight range, is we let n get big enough, it's incredibly, incredibly likely to be within this range.